rather than going through this, this other regular communications. And I take this opportunity to introduce Mr. Engineer Ravindranath. He did his BE Civil from NIE Mysore in 1984 and did his post-graduation from PSG College of Technology from Coimbatore in 1987. And he has worked in various construction organizations like Sharvana Construction, JMC Project, etc. for more than 10 years and gathered the site experience, very good knowledge of this thing after working various prestigious national and international projects. And in 2004, he started his own Ravindranath and Associates in consultancy. And I'm very happy to note that he is doing the architecture as well as the structural works from the consultancy. That should be the motto of all our consulting this thing. We should not leave that one part this thing to exclusively the other profession. We should be always part of that. Then he is very much interested about and passionate about eco-friendly designs, and he has worked with so many organizations in like tsunami rehabilitation works with NGOs, and he is very active ACC member, and he was Secretary General during 2007 to 2009. I welcome you, sir. And introduction of Dr. Ram Prakash, our moderator, Engineer Ravindranath. Then I request all the participants to put their queries and questions in the chat box so that at the end it will be taken up from our moderator. Thank you, and handing over to Engineer Ravindranath, sir.
Good morning, all of you. Good morning, Dr. Ram Prakash.
Good morning.
Good morning, Shrikant. Thanks for the very nice introduction. And I would like to mention one more point in that. Today's speaker, Dr. N. Ram Prakash, happens to be my professional guru. I started my career under him in 1987. Today being Teachers' Day, it's my privilege to moderate the lecture given by him. It's a privilege and honor to be there. Thank you, Doctor.
Thank you.
To introduce Dr. N. Ram Prakash to all the audience who needs no introduction because he is such a familiar personality with our community and in our association. Needless to say, to do my job here and then to introduce him, it's an honor. So let me start introduction of Dr. N. Ram Prakash. He graduated from Bangalore University in the year 1967. He went to after that to Indian Institute of Science and obtained his PhD from Indian Institute of Science, Bangalore in the year 1975. Just before this, when we were talking with him on his experience in Indian Institute of Science, where he had an opportunity to work with various scholars of this industry, to name a few, Professor K.T.S. Iyengar, who has been very, you would say, a father of, on all civil engineering and structural engineering aspects. So he had a great opportunity to get trained under him, and then Professor Chandrasekhara on shells and spatial structures. So to name a few on this. He has contributed to the torsion and shear provisions of the Indian standards IS 45678 and 456-2000 Code of Practice for Plain and Reinforced Concrete. In his professional career, he has been founder and past president of the Association of Consulting Civil Engineers, an organization of more than 5,000 engineers all over India with about 23 centers. We are all attached with it. And then he is the vice president of Indian Instruct, and he was also former vice chairman director of National Cooperative Bank, a successful cooperative bank with about 3,000 crore turnover and a top cooperative bank in Karnataka. He practiced as a structural consultant from 73 to 80, and a step forward, he started as a project management consultant from 80 to 90. And now he is a project consultant from 1990 onwards on various platforms, the projects. He handles varieties of verticals of this, name it concrete structures, steel structures, or power sector in many of this. He has a very varied interest in many aspects of civil engineering and designed many conventional, unconventional, large span buildings in India and abroad, concrete and pre-stressed concrete. He has been technical and quality auditor and peer reviewer of many projects. And feather in his cap is, he has also appeared in the Limca Book of Records in 1994 for the design of 88-meter diameter lamellar dome structure for a cement factory near Bangalore. I was fortunate to get involved with him when I was working in his firm, though it was at the end stage, but really it was a great experience to work on this project. And most recently, in 2016, he was awarded the Outstanding Concrete Engineer and Award for 2016 by Indian Concrete Institute. He's an avid trainer of men and companies and endeavors to give back to future generations what it needs from his and other panoramic experiences. To add a few more points, he disseminates the knowledge to all the people who come across to him, to either to civil engineers or to the other fraternity. He believes in dissemination of the knowledge which should percolate to the next generation and start doing much more. Now, we all are looking forward to this topic of case studies with Appurtenant unique challenges encountered and circumvented in heavy-duty industrial steel projects and large-span and light-gauge steel projects, including space structures. So over to you, Dr. Ramprakash. We are very eagerly awaiting to hear from you.
Thank you, Mr. Ravindranath, for those kind words. I also wish to thank ACC India and ACC Bangalore Center, more particularly Mr. Rajesh Kannan, Mr. Srikant Channel, and Mr. Savina Kumar for giving me this opportunity to say a few words today from what I have been through in my consultation. And I welcome all my colleagues in the participants as well as the participants for this lecture. I have particularly concentrated on the steel today, so it might be that much of the participants would be interest maybe in steel. Yeah. Sorry. My talk today will be on case studies with Appurtenant challenges in heavy industry, light gauge industry, and also space structures. So this might be the topic that I will be trying to cover today. My presentation will be in the following. It will be in the introduction, the preamble, some of the spread planned to be covered today, case studies listing in various parameters, and project-specific coverage will be the thing, and then with conclusions. The thing is that steel, as you know, is a very versatile material. Most of you may know this, but thanks to an engineer called Gustavo Eiffel, a company, his company designed and built the wrought iron latticed Eiffel Tower in Paris to show the world that edifices could be built in steel. It's unimaginable that a man in the 1860s or so could think of doing something of that kind to show people that steel is one of the things in which you could build some edifices. I have been on this and I have personally seen the giants and gone on the lift above and things like that. Hats off to them. We keep boasting about what we do, today. But this guy did it in the 1860s and showed everybody what a versatile material steel is. It's light to handle any which way if most sections are available in the market. Creations are possible in a multitudinal way in geometry, all as per dreams which way. Mostly used, sorry. Mostly used where systems can sustain tensile forces, where periodic inspection and maintenance is a natural activity, and where aggressive environments can be circumvented by appurtenant technology of treatments and coatings. That's the domain of steel. Standing example are the multitude of canopies tethered by tensile systems in the Western world. If one travels to the Western world, you see the difference between what's happening here and what's happening there. You suddenly see the tensile systems coming into place. They're more confident of the tensile system. But today, India is also getting there, as can be seen in the incorporations of board canopies and awnings, which are tethered by tensile systems. The key factor there is that it is of the maintenance and periodic inspection, which is one of the factors. Now, no longer the adage fit and forget in the built environment. Also, this adage was to fit and forget many of the creations, not revisit them annually or once in a while for maintenance, or as in the Western world, it's more for insurance coverage and all that mandates that a professional inspect and give a certificate every few years. A new genre has been thinking demandingly and boldly trying out possibilities. Now, no longer we are tethered with what we were before. We are getting out more demanding and bold structures. Of course, the reason why tensile incorporations in projects something is clouding this. This display is clouding this. I'm not getting the full screen out here. Okay.
Now it has come.
No, I've got one display here, which is not going out. I just want to remove this.
It's come out well, I mean, correctly, sir.
Yeah, but I have something coming in my way here.
In your system.
Yeah. I wonder what this is about. I wish I had the system here.
Sir, I think you have to click below that play. Last time you did, no, sir?
This display of your video is coming in the way of the material.
See, sir, that 93% is showing no below. By the just adjacent to that, there is a icon. Can you click that?
Normal, is it?
No, left side.
Oh, yeah.
Slideshow.
Slideshow. Yes.
Yes.
But your your image is coming in the way. Image of now Ravindranath. I wonder why that is coming in the way. Last time it wasn't. How to get rid of that image?
Oh, then you have to adjust in the display, sir. The floating panel view and side-by-side view is there, no? You have to click that side-by-side view.
Every time I have to pull this out.
No, sir, actually.
The display will be affected. No?
Yeah, it's not coming because the notes and other things are coming full screen. If you do it, I think that would be better.
So press F5, sir.
Pardon?
F5, F5.
Yeah, I made F5, but this video of somebody that is ACC now is coming in the way of this thing matter.
Sir, that is there in your system only. You have to adjust it, sir.
But for participant, is showing your presentation and your Facebook. Now it is perfect, sir.
That video is still there.
Hello?
Yeah.
Hold the image, sir, and drag it.
Pardon?
Hold on your image and drag it. Drag it to one corner of your screen. Mouse. Is that okay?
Yeah, I think so. Okay. Okay, sorry about this. Of course, the reason why tensile incorporations in Project Abroad exist is because of the existence of good interplay and participation of multiple technocrats like mechanical, chemical, civil, glazing, facade inculcators, managerial personnel, quality assurance people, fire specialists, and maintenance teams. There is a good interplay among all the participants. What's difficult for one technocrat may be easy for the other, is what I found, that what is difficult for a civil engineer may be very easy for a mechanical engineer. I have examples of that. Periodical inspection of insurance companies by professionals before renewal of insurance has helped. Add to this that most steel work abroad was done in steel fabrication factories with least work at site, making it reliable and more. Then there were factors of lifting, handling, and placing assistance easily available. Because of this integration of technocrats and creators, and people went wild and bold and convinced clients more to follow. Isn't it that all want something better than their competitors and one of a kind to fill up their ventures? That is the spirit. So we salute such for the environment that has been coming up, each standing out and tall next to the neighbors. But a word of caution to situation in India. Unless a quantum improvement and assurance is there of quality and sustainable delivery, we cannot say it for India. Now, the preamble to this presentation is we hear a lot of presentations on theories and softwares on how to design, how to detail, how drawings and specifications should be, what to be in the product mixes, how to manage, etc. However, it is common knowledge the lie of the land involves first the approach, then the game plan, plethora of nuances required and circumvented, and finally the nitty-gritty of day-to-day endeavors and course corrections towards culmination of the envisaged goal, notwithstanding the egotisms of the genres involved. Add to this the need for robustness, sustenance in the built environment, economical dictates and at sometimes limited sections material spreads available. This is one of the things that have kept us behind.
The all new and personalized learning app.
An attempt is made herein to transfer some of the above to the uninitiated youngsters and posterity for the wide spectrum of the consultants project of archives. Subject is addressed on the aspects of concept, design, economy, acceptability, and rigidity. The different projects that are going to be covered with are put on here. You see the Almaty Dam powerhouse, which you see here. This is the Almaty Dam powerhouse that we did. 5,800 tons of steel. It was a big experience. Of course, I think somebody has to mute their. Can you mute? Okay, the space structure that I did, about 88 meters diameter for a cement plant. And then these are for the space structures. And this is the Ganapati Sachidanand Ashram a prayer hall, 3,000 capacity, which is fan shaped, which you can see here. And I had I had a couple of other things. One challenging one of a space structure for a stage pop show, and then the petro canopies that we did, about 350 numbers in India. So you can break down today's subject into two parts: heavy duty fabrications and light duty fabrications. Among the heavy duty fabrications, one was a high-speed cement kiln and a retrofit of one of the preheated towers. And then there was a wagon tippler in a cement plant with a tunnel connecting, which was a challenge. And large span conveyor galleries. The span was nearly 50 meters plus, 55 meters to be exact. Then the powerhouse I talked about comes under the heavy duty category. I had a steel mill rehabilitation, which was interesting. And we had to do a data center retrofit for exceeding excess loading. And I did a factory which was state of the art under project consultancy. And another one for a corporate, which is a fabric spa. And one of the most challenging and demanding was a 60.5 meter stack for a gas-based plant. We had to do optimized design, optimization to the maximum in this 60 meter stack in India. In the light duty fabrications, we have come across a lot of trusses in small factories with and without cranes. Then, of course, the Lamellar Dome that we saw, the Ganapati Ashram which we saw. These have light duty tubes, and then waste silk factory also I had, which had light duty fabrications. And I did a space structure for a Skylight dome for a mint plant. The freestanding folded plate dining hall for Woodridge Resort near Bangalore, which was one of its kind. And the pop show space structure, which I told you, and the petro canopies. These will be covered today. In the two types of fabrications, there are some parametric factors to be kept in mind. In the heavy fabrications, cutting, forming, welding, and handling issues are many. Thicker welds, and for testing too, testing of the welds. Those are all some of the parameters. You have larger bolts, and you have torque spanners. You need for torque spanners and things of the kind. You have a lot of safety issues, and I came across this OSHA standards when I was involved with one of the multinationals. OSHA standards, AIC, according to American Institute of Steel Construction, we had in one of the projects. heights and spans are larger in heavy fabrications. To give you an example, Almaty Dam powerhouse, the column was 43 meter high with 250-ton cranes at 40 meters, things like that. And then when you do a heavy fabrication, you have to have a good inventory, of all the materials that are required, because they're not easily transportable, So it takes time for them to reach wherever you want them. So then you need multiple tower cranes for handling. One will not be enough. Maybe more than one or two or three. Then logistic planning. Then you have issues of health, vertigo, life belts, harness, all of this, because you are going to be in places which are very tall. Then in the light fabrications, you come across profile cutting, slotting, and welding handling issues. These are the things that you can come across. Many people would not know profile cutting, would not do profile cutting correctly, the slotting correctly, and the welding. Welding is one of the things that eats up the material in a tube. So in light fabrications, one has to be concerned about this parameter. You have thinner welds and thinner bolts, and then you have delicacy issues. You can't just deal with them without care. Generally, they are for lesser loads and product mix inventory. You can still be off in your inventory for small sections and holding up projects. And here you could do with derrick handling, and then sequencing erection for deformation control. Most of the creations are likely to be deformed if they're not handled properly. Then you have also secondary working platforms, etc., and derricks to support them and things like that. I've always wished welds and weld tests were automated and recordings made as possible by robots, as in autoclaves. One of the things that I found in practice was this is a big ask. Welds welding with certified welders with the supervisor and recording of each of that. And I'll come to that about sequencing and things of the kind, and deformations after. In one of the heavy-duty projects, the Mysore Cements, I did something about a high-speed kiln and a retrofit. First was they had the 2 or 3 preheater kilns, which were some 10 meter by 11 meter by 50 to 55 meter tall, made in RCC, reinforced concrete, and they had loadings of 150 ton on them existing, but they had to increase it to 250 tons loading. So they had asked us to see whether it should be demolished or it could be retrofitted. We went for the retrofit in 2 of them out of 3. The third one we are recommended demolition. Challenge was to integrate and weld the slender framework and certify the workmanship in the 80s, when only epoxies were being imbibed into the market, and the retrofit was a danger word with respect to old construction. Many persons, would not want to work in a place which is not too safe because of the slenderness of the columns that were cast earlier, and also that there were missing, the drawings were missing, the designs were missing, and you had to start from there. Uneven and inaccuracies of the concrete surfaces didn't help either. Sometimes bulgings are there and things like that, which you had to take care of when you did retrofit. Then came the era of the high-speed kilns. The speed of the kilns increased 2.5 times, 3 times, and things like that. And we were suddenly told that instead of the 2 preheaters or 3 preheaters, 1 preheater will do for this high-speed kiln. So we were asked to design this preheater, which was about 11 meter by 13 meter by 60 meters, and we did all of that in steel. So that was one of the experience, with respect to a heavy-duty project, a cement plant. The challenges were that many contracting agencies went away than take up such work, because at the end of it, they were wanting the certification that it is safe, it will be safe and can be guaranteed. Those were the days in the 80s. Thus, more responsibility and more supervision of all systems, components, and materials was asked from us. Then we came to the Raymond cement plant where we did the cement wagon tipplers. You know, the wagon tipplers have deep excavations of 60 to 65 feet with tunnels and conveyors underground involving deep soil investigation, deep excavation, steel tunnels, etc. The challenges were to get done all of the above with challenging designs, including retaining with laborers in the 80s without experience, ensuring safety in structure and in the facility. The interesting thing was the man who did the soil test. When we had to source him, we found very few all over India to go for up to 60 feet, 70 feet, and 80 feet like that. Then we had the large span conveyor galleries. In our space structure, which was 88-meter diameter, there was a conveyor gallery which was 54-meter span. In those earlier times of the 80s, industrial activity became very demanding with larger spans and larger loadings. This was one of the largest of them. Highly economical designs were demanded with heavy performance characteristics, notwithstanding the limited published literature, interplay and interactions among the fraternity. Many people would not share their experiences of what had been done, or they did not have the experience of that. Some facets regarding seismic demands, performance feedbacks, geotech certainties were just surfacing ever so slowly. Even the codes rarely updated, stipulations and foreign codes were hard to come by. This is the scenario which you face it's once in a while. A conveyor gallery of upwards of 55-meter column tree spacing was required for 88-meter diameter stacker reclaimer building. And you imagine the deflection control that we needed to make for this particular thing, but still it has to be economical. So it had to go through a puncture through the space structure, and so it couldn't be too big. It was very challenging and demanding and entailed extensive care in design, detailing, factor of safety possibility, as also deflection control, etc. Each and every facet was identified and controlled to a large quality functions. Severe quality tests of sections, plates, welds, bolts, soils resulted as differential settlement or the hidden danger too in this large span. And then came the Almaty Dam powerhouse. The scope of work was the entire construction of civil and structural work to accommodate 6 generating units. Columns, as I said, was 43 meters high. The factors that come in tall columns is the deflection and the control of deflection with respect to the cranes also not going off the rails due to the deflections. There they had 2 cranes of 150 tons each, which is huge, and structural steel components were fabricated outside powerhouse as a parallel activity, while substructure works were in progress to enable speedy construction. The project was for 24 months completion, including design checking. Highly optimized design and detailing was carried out in 3D analysis in 25 days complete. Involved fabrication of 5,800 tons of steel. In peer review, we were told that the reviewers do these designs in 2D, whereas we had done in 3D, which surprised us. And that brought me to the fact that a peer reviewer should be able to do better than you, or he must have a different software than you to do a peer review, not otherwise. Out of 4 fabricators shortlisted by us for the job, 3 were skeptical of a time of 34 months. They were talking about 36 months. One was very confident from word go. We got a doubt whether he knew the subject, he was understanding the subject. And you won't believe it, he delivered in 19 months, which was a record. When we interviewed these 4 fabrication groups for the execution, first 3 of them were adamant, and they had not much work in built-in sections. It was all built-up sections with plates, And then when we asked about well test, even well test, they could do for only 40% of the wells or less. This fourth agency showed no change of expression for all above conditions, saying he has done plated sections recently, etc. too, and said he'd check whatever percentage wells are needed. And we sat up and we were relieved. This agency did the work to the T and even made ready in record 19 months an indication of rare skilled workmanship and management, which was really a success for all of us. Then we were challenged on to a steel mill which had to be rehabilitated. The existing steel mill building was swaying whenever the cranes were used since 2 years. Since it was a 4-year-old four-year-old factory, and since 2 years it was swaying. And we were wondering what they had done before. They said that 3 consultants had given cursory touch-ups and not recognizing any danger, which surprised us because we could see the things stuttering and moving and things like that, the top being very dangerous. A famous consultancy group and a #1 contractor of India was involved in the design and construction, which surprised us that even it happens with the top brass in the consultancy and contractor. Then a lot of sparks had flown from the consultant group to the contractors group and vice versa, and we were caught in the cross stream. And we had to, the people, instead of looking at the top, they were looking at the bottom, saying plinth beams are not okay, and things of the kind. And I was wondering whether I was wrong or something was wrong with me, because I was looking at the plinth beam. Plinth beam was the least of my problem. My problem was when the roof would fall down. Being the fourth call was told by technical director. When I entered the complex, I was enlisted by the chairman. The technical director there said there is no need to see the factory, and he was asking that nothing will happen. These things happen in steel mills. But the chairman insisted we do the job, and we took it over. We found whole building severely swaying and declared danger to the factory. All the factory was working in full steam, and we were surprised that nobody said anything about danger. Even the we were on detailed inspection of all aspects and going up to the roof leg. I saw crane nearly at the edge of the rail. Got movement mapped by total stations from outside, different levels. Finally found that the concrete columns had cracked at the roof leg joint, and top roof portion was moving regularly. It was not in synchronous movement with respect to the bottom. So you can imagine that the top would have given way, especially being a concrete column. Such lag diagnosis was rehabilitated and set right with steel interventions. So we could do that, and this was one of the successful things we were acclaimed for. Then we came across a data center retrofit. A data center's upper floor was designed for 600 kg per square meter, it seems. It needed to be strengthened to take 1500 kg per square meter without disturbing the ground floor. They wanted to extend the data center to the first floor. This was a big challenge for us, and it was also that we could not do anything on the ground floor. Then we suggested a castellated roll section grid attached to the roof at top in the false floor, gap of 750 mm. There was a false floor. There's a gap of 750 mm, which we said we'll use, and we used castellated roll sections. Other consulted suggestions involved new columns and putting outside existing building and concrete grid roof, which was cumbersome. All aspects of combined behavior were checked out in this particular thing, and we even had suggested an alternative of a space structure for the 750 mm depth. Then we came to a power gear factory in Bangalore. The new power gear factory design was brought to me, And we were asked to do 4 separate sheds. Ordinary, gable sheds were proposed and loosely linked to each other. And the site was more or less skewed. There was falling ground in the site to add to it. And we said, why is this being created this way these days? This was in the 90s. And we said that we could do better than this. And fortunately, this person was the promoter of the factory, was from Indian Institute of Science, a master's degree holder. And he would listen patiently and ask me, how can you convince me? I turned around and said, this is archaic, putting 4 60-40 sheds in a factory and linking them is all given up long now. We revamped the whole design, incorporating a single integrated unit using the falling ground and north light orientation to get the lighting aspect also. Incorporate double wall with hollow for west side wall because of the heat that would be radiating. Resulted in a fabulous professional outfit and was told had become the #1 factory in the industrial area. We approach all design as though it is our own facility and not somebody else's. This is one of the factors that one should have when you approach anything that has to be created. Appreciation will follow, including satisfaction for you. It's win-win situation for all. Even the contractor who fabricated everything to the T got us 2 more factory projects to boot, showcasing this fact. But once the incident happened here, the contractor who did this job, he had a very good experience, very well-known fabricator, and where we had given compression, what shall we say, jointing in the bottom, he had changed it to tensile connection. So when I asked him, why is it that you have changed it? He said, there's hardly any compression coming at the bottom. So why should we make a compression splice, a connection? I turned around and said, what happens to wind? Then he said, oh, the load is very less of the wind. So a person knowing the subject also can, change you and make these changes without, asking you, even though he may be a senior person. We got that thing changed. I told him, I'm sorry that I don't agree with this. And this is one of the things that you come across, whether they are senior or junior. And then we came across a fabric spa factory to be done in Bangalore. And sure, once again, this was the 6th proposed factory for the corporate company. We were just asked to replicate from any of the existing 5. We just said we have done 5 all over India. You can replicate any one of them by going around and it will take you around. You choose one of them and then do it here. I said we could do better, and we did. First of all, there was a large falling ground in this particular complex, and we incorporated half basement for economy. And then we found, but the soil tests had to be done extensively, and then we found that 1/3 of the site was with rock outcrop. So then we said, oh, this is another of the problems. But luckily, the basement portion was not with a rock outcrop. It was far from it. Then we had an optimized design done to their product flow. We worked with a contractor who was experienced, and really hats off to him, because he integrated with everybody so well and participated in a grand manner. He, with contractor, worked out logistics of fabrication, erection, and finished factory in fast track mode complete. He would fabricate everything inside the factory and erect them. And so we had done the screed concrete for the whole factory before itself, so that this could be done faster. These are things which come back to you, to give you what satisfaction you need. And finally, I was told by the chairman that we had given him a facility of international standards. And recently also people said that they've been getting a lot of orders seeing their factory. Then we came across a 60.5 meter stack for gas-based plant. A stack is somewhat like a chimney. But stacks have large openings from bottom to top in the shell of the stack. So this is one of the things that intrigued us to see how to make an economical and safe design. You have a large opening from bottom to top. Then we made a most economical design after many alternatives were conceptualized, because it was in steel, and we were wondering what all things we could do in steel to make it the most economical also. We made a FEM analysis in depth with and without strakes. We had put stiffeners, strake stiffeners, and we made it most safe. We had wanted to make it most safe because it was very stringent on the loading and wind factors and the seismic factors. And it was most economical. It was obtained, design was obtained after trials with many variations. So although you can just do some and then hand it over, we always try to make many combinations. And this is where I would say that people in my office also, they participate in a big way and they come out with ideas and come out with alternatives. Then finally we zero in on what's the best for the office to give out. The optimum solution resulted in a 3D analysis and design including seismic conditions. Then we were wondering who's going to peer review this. Then we were told that we will not peer review your design. So this is one of the things that we got, an accolade that we got after they got confidence in us. This was a fabulous experience to the team to exercise grey matter fully and effectively. Only confidence was that the fabricators were experienced any which way we wanted. That's what we are bothered about. High level welds, testing of the welds and things like that in 60 meters was a challenge. With that, I finished the heavy duty part of fabrication. We come to the light duty part. Now, trusses in small factories with and without cranes is something we came across in the earlier stages. And we thought these are, very simple matter. Usually I just don't give it to my juniors in the office to do it and things of the kind. We never treat any job as something which is, very small and things of the kind. Then we had some interesting thoughts when we came across in truss fabrications. We come first to simple factory in about 2 or 3 cases referred to us where the trusses have precariously sagged. They had sagged, causing fear to the workers there as well as the management. In 2 cases, the designers had taken sections from some handbooks given by steel manufacturers and made the drawing. And they said we have followed this manual given by this steel company, and I don't know why it is sagging. You ask the steel company. On inspection, it was found that the tube-to-tube fabrication was lax, as there were no gusset connections envisaged for economy, and the profile cutting needed and welding was done crudely. In one case, one designer had used a foreign handbook and not checked the wall thickness of the tube in the handbook and that in the local market and made his drawing. So the wall thickness of the tube is also a very big factor in the strength of any design. So these are things which you come across. And the thing in these projects were many a time the clients are asking whether the whole thing has to be demolished and redone. Much of the cases we have said nothing doing, you don't have to do that when we are around. So we could strengthen many of these things with proper assessment. Then one of the things we came across is trusses being plain. A job where we warehouse, 3 warehouses we were doing, the job of the top truss fabrication was given out and inquiries were asked. Most of the people quoted 10% less than standard fabricators. So the client is saying, I will save 10%. Why should I give it to standard fabricators? I will give it to one of my men. And that man was known to me. So I said that, why is he not doing my design? Why is he doing his own design? He says he knows design, so he is doing it himself. Then I said, then don't ask me. I'm not going to look up. I'm looking down on the factory only. If he doesn't do a good job, you are going to suffer. It's like that. And the job went on, and the man finished the job. And I was asked to come and inspect and then give a certificate and things like that. When I went there, I found the bottom card had got bent, and it was not in the plane of the top truss. So trusses being plain, bottom is one of the things I never thought would be possible. It had been done by a fabricator whom I knew, who was a friend of mine. And he didn't even come for my visit. He turned around and said, ask doctor, whatever he says, I will do. So rehabilitation of that he was prepared to do, but he was not prepared to do my design. So it became a very ticklish issue. Anyway, we tackled that. Then many cases we have bottom cord ties missing, and bay bracings are missing. And in the particular previous case, the spa, in the 5 of the factories that we went, many of the places the sag rods were only in half of the building, and the other half of the building had no sag rods without any change of sections. So these things happen in many of these truss fabrications. Then you come across this crane fabrications in your systems, even in light-duty factories. In cases where cranes are involved, more laxity is displayed. A person who hired a built place asked us to check and certify its stability, especially the crane capacity, because it was a MNC. Work was done turnkey by a fabricator who first said it was designed for 5 tons, but said it could take 10-ton load. So the client was saying, which do I take? Then I said, if you ask me, take 5. He said, why don't you check it for 10? Because I need for 10. So we went, the client got doubt and wanted confirmation. We found it suitable for only 5 tons only. Imagine that there are people who are in the fraternity who could take risks as such, in such cases. What would have happened if it had been a 10-ton crane in that factory? And then we come to the 88-meter diameter Lamellar Dome, which we did in 1987. This was a landmark thing because I was told by the Mysore Cements that I should just execute a German design given by Humboldt for this particular thing. This was a stacker reclaimer building. You can see the massivity of the building by the size of the person sitting here and standing there and things like that. So I said, why should we do this thing, German design? Why can't we do our own? He asked me, are you capable of doing something of that kind? And, having done PhD in Indian Institute of Science gave me a lot of confidence to say yes. I don't know why. But, I said yes. And he said, okay, you tell me what you can do when you ask for their drawings and then take a decision. So in the next 15 days, we did the whole design of this. And then we found that we had used 350 tons of steel. And the Germans had given a design for which 450 tons of steel. So this was a 88-meter diameter, and it was 13.5 meters height, a dome, with a springing height of 4.5 meters for a core stacker reclaimer. Roof is designed as a double-layer lamellar grid with an opening for material conveyor gallery. This is when I came across the lamellar domes. There is a book on space structures by Professor Minkowski, which I had seen in the libraries. And I've been fascinated by these domes which are being built. Buckminster Fuller Dome and things of this kind. So I just saw that there was one lamellar dome, and I was wondering what this particular thing is, and immediately I felt that this was torsionally very stiff, because of what it is. You can see the configuration. You will see that in the next slide about the detailed configuration. The configuration is such that it is very torsionally stiff. And we had one thing in this, that the conveyor gallery was coming through here into this particular building. there's a conveyor gallery from the stacker reclaimer, which was sending off the coal. So we designed this whole thing with 350 tons of steel, and they would save 100 tons of steel. And they asked whether we are confident of doing something of this kind. And then they put a condition that we should have 2 contractors who can do the job. Then only will be considered. I said, I'll give you 3. So our scouts started to see all the people and things like that. Finally, we could get only 2. The third person said that this is too risky because there's an opening at the roof and things of the kind. So you come across idiosyncrasies even among the seniors that they were still afraid, so they won't go into danger zones. Here, the roof is designed as a double-layer lamellar grid. We put a double-layer grid roof, and with an opening for material conveyor gallery. All the members are designed as truss members with top and bottom cards having 1.5 meter height. So we had the issues that it has to be stiff and things of the kind for handling also. Although light tubular sections were used, the project was a heavy-duty project by its size and challenges. Although it classifies as a light-duty fabrication, it is a real heavy-duty project. At the apex, a circular compression member in place is designed. I'll show you the photograph after. All the joints were developed and were made of plate detailed to join all at top and bottom cards spatially. An experience happened that the tender was floated and we had to make it most economical. So I was seeing the space structure joints and got a quote from one of them. This was in the 1987s. This was around 57 lakh rupees, 57 lakh project. And the joints would have costed double what would have costed by a fabricated joint. We had estimated the fabricated joint to be 6.5 to 7 lakhs, and the space structure joint, the ball joints, there was only one agency which was doing that with a German backing or so. It was costing 13 lakhs. So this was not acceptable to any of the contractors because the cost would be more. And also the client is saying that it was most economic. So our joints were all developed by us and are made of plates, detailed to join at top and bottom. We developed our own plate on 3D geometry. You know how these things connect to that. In those days when you didn't have large systems to help you. At the springing level, hinges with pin rods were provided. Roof sheeting was of galvanum corrugated sheets. So this is one of the things that projects which was done. Here we had the approaches to this was that national team sourcing, inducing and convincing people. This is one of the issues because this is a different type of roof. Economical costing with respect to the joints, all aspects using nationally available materials and technology, firefighting, all encountered day-to-day hurdles, achieving goal in delivery. These are the different parameters that you come across in any particular thing of this kind. You can design, draw, and maybe even cost such a thing, but it has to be transcribed onto ground. It gives you all the challenges that you require. The German design was a radiating type of dome design and Humboldt, and it was asked to be executed with 450 tons of steel using Indian contractor. Our alternative Indian design of lamellar grid was with 350 tons of steel. We were asked to convince and get 2 persons for this job. We finished in 9 months using only 240 tons of steel, saving nearly 200 tons from the German design. Of course, we made some changes. The change was we used YST38 steel. At that time, Nagarjuna coated tubes had they recently put up a factory, and they were wonderfully giving us YST38 steel tubes, which nobody was picking up. Rarely used, and it was used as YST25 tube by many people because they didn't believe it was 38 and all that. And I said, if the testing and proof is guaranteed, why not use this? And this is one of the great things that helps you in hearing people making their presentations, even in this pandemic times, you know what you can create with what. Then we were asked by Humboldt after this job was over whether we could do this in Australia and Yemen and things of the kind. So this is where it helps you to work on steel and do it well like this. Finally, the client said, "Doctor, you have made my dream come true." To which I said, "Sir, you have made my dream come true. Because for every man like me, I need a man like him." If he had not said yes to my design of 100 tons less, and if he had not bothered about my credibility to get contractors, he would not have taken to this job. But finally, I want to pay a tribute to this man who's in this photograph. Particularly, I put this for this particular thing. Ode to the man whom you see in the photo is one Mr. John Jacob, the project manager, and his team of 75 workers who gave their skill, blood, and toil to achieve the innovation. Imagine what this entails with the workers. 8 o'clock, the man goes up. He has to do some connection in this end or that end. He has to walk along this, go to that point, do the bolting and things like that. Another thing that happened in this particular case was we were all thinking that we could do sector by sector, one of these sectors go radially. Then suddenly it occurred to us that instead of going radially, we should go circumferentially. So derricks could be there to support each joint, and we could build ring by ring, and go to that. Then we found that even the tolerances we'll have to check every time. So in this particular thing, you can see the lamella, this thing, what shall we say, geometry, which gives you a lot of torsional strength, not only economy, but it also gives you stability. The innovation tangles in this are first of its kind in Asia. We were told this is first of its kind in Asia, using three-dimensional superior lamellar configuration in plan. Professor Minkowski, the father of space structures, he had come for a seminar and he couldn't believe I presented this paper. He couldn't believe we had done it in India. He wanted me to show it to him. I took him there and he was shocked. He said, "I'm going to tell the world that this has been done." So this is not only due to us, it's due to a lot of people in the chain, upstream as well as downstream. Three-dimensional analysis and design was made, resulting in large savings. We always believe in doing three-dimensional analysis. We never shortcut to two-dimensional analysis. In many cases, I've seen people doing components in the two directions, adding the two and making the provisions, which is not, they don't know the interaction, or they don't know the definite advantage of doing 3D. Opening in roof for the conveyor gallery posed a challenge in design since it became a large unsymmetrical structure. Opening in any roof is a big challenge because it's just like puncturing the strength of that particular dome. Construction was planned to be done in quarter segments with necessary support system at nodes of only one ring at a time. And we changed over to one ring at a time, and this is all because of teamwork. High-strength tubes were used for the first time in India for such a large span, resulted in most economical structure as it consumed 250 tons of steel compared to 450. I finished this by showing you the central dome with everything removed. This is the central dome that we did. And when we measured, this was the 20-meter diameter, and we measured the ovality of this. The ovality was only 20 millimeters. Over from 88 meters to 20 meters, the ovality was only 20 millimeter, giving us a kudos for all the people involved with this project, including the 75 people who toiled in this particular thing. I'll jump, leaving this because the tolerance thing also is a factor. Leaving this, I'll jump to the next project, which is Nadu Mandapa in Mysore. I was asked to do a fan-shaped building in Mysore, column-free in 2/3 of the portion. You can see it's all column-free. It's a music hall with acoustics, fantastic acoustics. And Swamiji cures by music. So music is a very big part. And this was funded by an American agency. I think it was Fokker Friendship or some that aviation people. He financed this whole thing. You can see the fan shape here. So this 2/3 part is all column free, and 1/3 part is half column free. So we did this project, and you can see the aerial view of this. But I have an interesting part in this particular thing, which was the entrance shell, which was done by a local professor in engineering college, because they thought, contacting me and getting it done and things like that from Mysore to Bangalore would be taking time. They just gave it to a person here, and it was incredible to see what he had done. Anyway, I'll come to that if the time permits. It is tapering from 75 meters to 25 meters, this particular hall. Springing level of columns is 12 meters. Now, the springing level of columns of 12 meters would entail concreting of 12 meters column. And so I was not sure of the curing of this particular thing and the concreting also. So I imbibed the curing compounds for this particular thing. The thing was that the devotees of this particular Swamiji were all seniors and former civil engineers and management people and things of the kind, deputy directors, and all that. And all of them would be looking over my shoulder for everything that I did. And sure enough, they're just saying, why are you using 16 mm instead of 12 mm? Why are you doing this? Why are you doing that? And, it was quite a thing. Now, I turned on one day, I put my foot down and turned on and said, you do it your way, I'll do it my way. This sort of thing. So it all helps to be a qualified senior person to put things in perspective. And sure enough, I got them caught in one thing. One of the vice presidents of some big contracting company who was a devotee. He had put in the foundation, in the footing, he had put the reinforcement 16 mm in one direction and 20 mm in another direction was given. And 20 mm was in the longer direction, obviously. He had put 20 mm in the shorter direction and put the 16 mm in the other direction. So when my assistant went there, he complained that they have changed the thing. So I called and he said, yeah, sorry, I didn't notice because I thought in the shorter span there will be more pressure. And so I put 20 mm. So I said that unless this thing is removed, I'm not coming to this particular site. And unless I made that issue, it wouldn't have been serious. The rest of the building, nobody interfered anything with whatever we did. From 2/3 of the area, the column was culminating in 20-meter segments, 20-meter semicircular stage for the orchestra and dance performances is the beauty of this particular hall. Whether we are Swamiji's devotee, I am not a devotee of the Swamiji, but still just to see the hall and when the music or dance performance is going is incredibly an experience. And we put up a video gallery here, the suspended video gallery we have put here because they take videos of all these things also. We used devotees of the ashram imbibed twin 30 centimeter column. Now 12-meter columns would have been huge, long columns. So I turned around and said that we'll put two 30 centimeter columns and get rid of the long column effect. Use curing compounds, strict tests including welds in fabrication and load tests done through local engineering college faculty. I don't want to say about that, all those faculties who came to do the load tests and things like that, things of the kind. When I insisted on 100% compliance from Swami, he said, I will give it to you. Seeing all these people, I never thought I'd get 100% compliance, but I did because the Swami came along with me and he wanted to see all those. Sorry, I don't know how I'm doing. Am I okay? Am I okay on time?
We are fine, sir. Getting along.
Okay.
Very nice. You have another 40 minutes, 35 minutes.
Okay, 30 minutes should do.
Yes.
Okay, next was a waste silk factory with Japanese collaboration near Bangalore, outstations of Bangalore. It was an outstation work. It was state-of-the-art design with open web tubulars spanning large span imbibed for economy. And we had the open web tubulars sections. Then the owners of the collaborators of the factory, Indian collaborator, had a relation who was a fabricator. He introduced him and said that he will do the job. When I interviewed him, he had never done tubulars. He never knew what is tubular, first of all. So I said, this will not do. Then he associated with one other who knew little of profile cutting or slotting in tubes. We had to teach, supervise extensively these people. And fortunately, we could get the welders, who were certified welders. That was the first thing I put a condition to. So most of the time, these people would be prepared, suitable for the next project. They're suitable for mine. Most others quoted very high, because it was an outstation work. Most other fabricators quoted very high for this job, and client would put his foot down saying, I can't afford these chaps and things like that. So I wonder why, but days are changing now. Young people are prepared to go anywhere to do whatever. That's the great thing about today. But in those days, there were a few of them who were fabricators, and they would dictate, and they would either charge more or never do. This design was being noticed by the Japs because they were very good at steel. They were all looking at it and having a lot of things. And one thing with the Japanese in this particular case, when they came first seeing all the drawings, master plan and all that, this was done by project. The whole project was done by us, single window. They saw the master plan and asked, where is the guest house? Then we said, we haven't thought of the guest house yet. We'll be putting it in some place soon. We worked on the factory alone because the sanction was for the factory. The Japanese told us that they want the guest house first and the factory after. So if you don't do the guest house first, we will not do. Then they asked, what is the reason? They said they will send 4 people and they will be staying throughout the construction of the factory. They'll be staying at the site. This was an experience to me, how people in different parts of the world work. Then we got accolades from the Japs for the design, but till the last tube, it was an experience because these people gave us a nightmare. Demanding precision welding was implied. Trained welders and weld test insisted extensively, and this it was very demanding. This was appreciated by the Japanese, but not the clients, although they wanted state-of-the-art and economical solutions. Many people come to you asking for state-of-the-art solution, the economical solution. A man came to me and said that I want something in his collaborator was from South Korea. He said, I want that factory to be replicated in Bangalore. Can you do it? This sort of thing people come out with. Then I said, it's only the facade that you're talking about. The inner can be what we need. Why do you need the factory to be replicated? So he said, what is that? I can't understand. He said, So this is what you come across in different cases. Then we did a 10-meter parabolic Skylight dome for a wind plant with polycarbonate claddings. Now the exotic thing is that they wanted half of it to be clad. The polycarbonate cladding was only for half portions with gaps in between, the other half being open. Saying that during rain there will be water falling and it will be interesting and things like that. In this particular atrium, I said this is nice, and we took it up just like any other project. We just took it up, and design was simple, but detailing and provisioning were intricate because alternate panels in cladding were to be left out to allow rainwater to pour down as a feature. Tube selection, jointing for exposed condition, etc. are involved. And we were worried about the tube corrosions and things of the kind, and sealing of the tubes. Tenders were also only one in number, because it was not something to write home what for a run of the day for every fabricator. Only one of them tendered due to the exposed conditions, fearing corrosion attack and failure of dome. After 2 rainy seasons, it was thought fit to close the feature. The thing is that you might want the rainwater to fall down, but it will not fall down in a column. It may splash to other places because it comes at an angle. One of the factors that we found, although it's exotic, It was later covered, and it is still exotic as a skylight, but not with openings. But the experience for us was where work was too much for any compensation possible or given by tender. This was a tender. The compensation was peanuts. With the effort we had to put in for that. Then we did a very nice folded plate roof for a dining hall for a resort called Woodridge Resorts. You can see this in the picture. These are the folded plates. You can see the single plane tubes. And the interesting part is the cladding is a rice husk paddy rice husk board. The cladding was that, and it is 75 feet diameter, and we have imbibed the A-frame columns to take care of the thrust. So one of a kind folded plate roof, dining hall for a resort. This was made in steel. Cladding was wood particle board of 10 mm thickness. Was a big draw among visitors, and A-frame columns took care of any thrusted base. So everything fell into place, and really resulted in something exotic for all the persons, as a dining hall. Now I come to one of the most dynamic and challenging things that we have come across, and one of the things in the fastest track that you can think of. Well, it's not fast track, it's double fast track, you can say. This is it's an unconventional steel structure for a pop show stage, 50 feet by 100 feet by 50 feet high roof at Bangalore, done in 25 days. Notice, this was done in 25 days. Post structure on ground, space structure was made on ground to be lifted to its position 50 feet high using two cranes having 50 feet high 4 columns were hinged and ready to move on trolley to vertical position with mass concrete foundation to each column. A lot of the factors that come in, you can see in this photo. These are the frames, different beams and things of a kind. And this is the space structure that with the cladding. Cladding was a fabric. So it's all of it on ground. And this was done for a group called Pink Floyd, which is famous in America. And I believe they are architects in America. So they're also into construction. They know about construction. We were involved with them. So they would also keep, looking over our shoulder, whatever was being done. In one way, it helped us. I'll come to it after. You can see the two parts there, and this is each one of them being fabricated at ground. Very convenient to fabricate on ground. And finally, the two cranes were put on either side, and the thing was lifted. You can see the two slings here, and this is the space structure taking off. And you can't see the columns here. What we did was we hinged the columns, 50 feet long columns on 4 sides. We put them and hinged it onto the space structure here, and we put it on a trolley at the end, so that once this is lifted, that would move into position and things like that. So we thought of all of this, just to make it in 25 days, and we were wondering whether it was only a dream or whether we can achieve it. This happened because somebody from National Design Institute, India, I had done some solar bus shelter for them. He told my client, I am the one to source if he wanted to put up the stage in 30 days. Most others asked for 60 days, it seems. We picked it up, got a vibrant fabricator, did design and drawing in 3 days, went to a crane agency, were told they had 40 years experience in crane lifting. Son seemed to have just taken on from father, was quietly sitting next to him, told 2 cranes, one of 60 feet and another 80 feet was available. We finalized the deal and started logistics. Within 5 days or 7 days, all this was done. We laid the plan to do space structure all on ground and lift it up. We then planned to hinge the column 2 to the space structure and lift with it, putting end of columns on rollers. would enlist 4 workstations to monitor the 4 corners, X, Y, Z, all during the lifting. Stage-wise recordings. We decided to do large box excavation for mass concrete footing for the columns using RMC. Once structure is in place and the plumb of the columns were established. Also, rolled fabric cover was fixed to structure to facilitate cover on 3 sides. Sides needed to be covered, so we put fabric, we hinged it onto the space structure so that it could be let down. First bloomer was that fabricator had put only 3 bolts instead of 4 in connections. The fabricator had been going on putting 3 bolts, and they have this habit, some of these fabricators, they always think that it will go short by the end. So let us put 3, the 4th one we'll put after. This was a shock to me, and we were telling them that we will not come to site if the 4th one was not on. But that was on deaf ears because they were so confident 3 bolts are good enough. These fellows have their own idiosyncrasies. Then stage was at 50 feet on one side and 55 feet on back side. There was one more bloomer. The stage was 5 feet falling. So it was 50 feet on one side, 55 feet on the other side. Just 5 days before D-Day, all fabrications had to be ready with cranes in place for our inspection. Second bloomer was the cranes had been installed reversely. 80 feet boom on front side of 50 feet and 60 feet boom on 55 feet back side. Then we asked the crane guy to change his mistake when he refused. He said, I got 40 years experience, nothing will happen when we lift and things of the kind. These guys come with all that. They have this guffaw to push you to risk. There was no use of all of his 40 years experience here. He couldn't understand that the undersling would impart bending on the end beams on the 55 feet side. He's not a technical person, he won't know. I'm telling him, he said nothing will happen, they won't bend. This is sort of thing that you come across. I relented clearance. The pop show inspection guys came and said the same thing I had said without knowing my observations. Both fabricator and crane guy had to relent and do as told. See, it helps many a time that you get the other people also. Otherwise, we would have just walked out of the project and it would have been a disaster. They would have lifted it with 3 bolts and God only knows what they would have done. Now the total station guys also, there was a bloomer, reduced to 2 on each side. Somebody said, why do you need 4? 2 on each side is good enough. And they've ordered for only 2 instead of 4. All these are cost-cutting situations which they don't realize the seriousness of all this. This was bad as constant monitoring every 5 feet during movement cannot be recorded on one instrument. So we had to give in very badly on this. So even the fellows who were running the total stations are all crimping. Oh, this, that, a lot of work for us and things like that. They would not be having any enthusiasm. Next, we checked the quantity of guy wires, 2 for each corner to tie down the structure while concrete cures. We had stipulated 2 guy wires, 2 for each corner while the concrete cures, because the crane will be releasing that at some time. Fabricator said he had enough and more guy lengths. On one day before launch, he had done guy each for only 3 corners. Crisis again, asked to use coil ropes at least also while he brought the wires. I would say this is Namkavaste work done, because they give you a lecture saying that I have enough guy wires to go around the world, is what he had said when I asked for the number of guy wires he has. These guys are all made that way. So the guy wires really, they don't know how important they are. It was then Pink Floyd Pop Group, who are also architect group in USA. They said, after this thing was all being done, they said, sir, we should have had the whole erection as a show, also with tickets, as it is unique work. We would have had a full house. I didn't realize that this was a possibility because we were too busy doing the work rather than saying that it could be a show, or maybe it could have been a show for our association also, or anybody who wanted to come, any of us. But we didn't get any bonus or appreciation of our groups because of our strict demeanor. When we asked for bonus, because of the large involvement that we had to do, They said you are too strict. Things like that. I don't know what is too strict in this particular thing, which all of you can judge by yourselves. Only we know what we went through wasn't worth it financially except for mission accomplished. We accomplished the mission and we were appreciated in a big way by the Pink Floyd group, but not by our own people here. Then came the petro canopies that we did, for the Reliance groups. This was a competition among 11 people from all over India and abroad, I believe. 5 were shortlisted, and we were only 2 of us finally got the job, and we were one of them. We got 350 numbers of canopies order, and they got some 150 or 200 or so the other ones. So this is one of the things that we did. This was an all India order among 11 tenders, international tender and specifications. All specifications were all laid out in UK. They all had international tender specifications and things like that, which we were very happy. It's so elaborate. They'll tell you where to stand, where to sit, where to not to do it. There's really encompassing is one of our comments on what we did. And we're so happy to work with a group of this kind. Only agency among all to have done all designs in 3D to strict deformation control, which intrigued us very much. I believe the other agency was doing this whole thing in 2D, analysis in 2D. I wonder how they are able to do this in 2D and give them controlled deflections. The controlled deflection in this corner is the key factor, controlling of that deflection. I don't know how they do it in 2D. It's all they deflect from there and deflect from here and add it to some kind. I don't know, but we were really, the technical directors were mighty impressed by the 3D that we did, and they even came to our office to see what all we do and things of the kind, which is really, something which helps you eggs you on what you do. Experience was excellent with respect to our innovative and design skills. I believe the man in UK said that this group, one of these 2 groups, is very innovative because we gave them a profile just like an eye fisheye. We said the canopy can be like a fisheye rather than this. Things like that. No fabrication, welding, or modifications allowed at site. All to be done in fabrication shop only. This is one of the conditions in the tender. It is just like heaven for us, because how fabrication at the sites are in the Indian scenario. So if you said that you will not allow any fabrication, everything would be done 200% in the factory, things like that. Felt very much down our street with respect to form, design, quality, etc. This was a real experience for us. Now I come to some miscellaneous in steel construction. We installed a fast-track newspaper factory in Bangalore in 60 days, flat, complete, in the 90s for Times of India, which was landmark those days. It was due to a dynamic contractor associate who took instructions on telephone and delivered 100% quality. The drawings followed next day, but you would say, what is the weld you are expecting, what is this, what is that, things like that. And I tell you this, those really give you a fillip. So accolades egg you on towards innovations day in and day out. Accolades like this from different agencies, our clients, gives you a lot of enthusiasm. Sorry. Then I had an international experience. This was in a solar panel structure. It was a solar park panel structure. Every design that we feel has to be critically viewed when you get associated with anybody, including the foreigners, the MNCs and things like that. So we said that there is a need for aerodynamics vortex action, which was left out in a solar park in Rajasthan, where wind and sandstorms are rampant. The panels are not mounted on ground; they are mounted little 3 meters higher to the ground. And they had left out the aerodynamic action and the vortex action due to aerodynamics. And what it entails is that the vortex action comes back to hit your structure, and there will be the panels will get broken or affected. And what they've done is they put just a simple cantilever particular frame. Strutters would release the panel from its tethers, which was pointed out, resulting in reevaluation by them of the sections. So we said that we could have a strut to control the deflection and things like that, and design for it, but they would have nothing of that kind. They said just change to Indian sections and do it. But they refused an idea of strutting by us for reasons unknown, maybe prestige issue, more economical could have resulted, which resulted in our walking out of the project. We don't wish to be associated with people who don't want to do safe structures. They're asking where is aerodynamics in this. That shows the level of whoever is talking to you. Next came the outsource company. We were involved with an outsource company. I was asked by an outsource company to join as a consultant and help them enlist people for their facility here in Bangalore from Chicago, then to train them, then to supervise the project delivered by this particular facility. This is the Chicago Total Outsource Company. This was in 2008. I put together a team of 3 experts, including me. It was the most enjoyable interplay with international, similarly employed team, ending up applauding our performances, even by being called the best among all teams of the company in different countries. Most times, if you put in your effort, I feel that the accolades keep coming in, and competition just disappears. So this was we were there for 9 months with this, and it was a very successful one. Then lastly, I want to talk about a consultancy in Malaysia for an industrial plant, where when I did not need to go to Malaysia. I could do the work from India because the soil profile was given up to 30 meters or so. Refusal was at 30 meters, and the full soil profile of all conditions was given. And I didn't have to go to Malaysia at all. I went only for the inauguration of the plant. And the contractor who was involved with the project was an Indian contractor who knew exactly what to do when I said whatever I wanted. So this was a real experience on the international sphere. Okay, I have a few conclusions which I would like to present. I have not covered PEB buildings here, which are important building ventures, although sometimes they are stereotyped. They have put facilities on fast track mode. But beware, there are PEB suppliers who ask you whether you want American design or Indian design, and they code differently for Indian design and code differently for American design. I don't know why they should do this. Obviously, it is the code that they follow. They might be following the American code, and I wouldn't have anything of that. Although I knew the American code, American Institute of Steel Construction was known to me. But when you are in India, we should do the Indian code. And if it's something better than the Indian code, in the American code, we take that. Then steel is a versatile material handled and well in quality and accuracy principles. Quality principles, accuracy principles are a very big factor in steel. You can't be a man who's a concrete man and come and do steel. Things like that. This skill development for each of this has to be well known. I've seen this in some of the facilities that have come up in India from the MNCs. They have a welder. A welder can do a welder job. I think it was Enron who did that. Dabol who did that. They have to have a supervisor standing there when a welder is doing the weld. No work should be carried out without a supervisor. And the supervisor is recording whatever is being done. Things of this kind should come in if you have to really do well in steel. And the more the players in steel, more the creations follow in them. So the steel fabricators being less in number before, the creations didn't follow. They used to do the same old thing what was being done, put a gable truss and put this and come away. and put 460 partitions and then create a factory. This sort of thing. It's time we all moved out of that. And we have. Anticipate further developments in making steel more comprehensive in compression too. Only thing was that steel being not very good in compression is one of the factors. Although I had a friend, Mr. B.M. Sridhara, who used to do, the tubes with fillings, and he would make you it's compressive strike as much as it has no more. But he was a great friend of mine and a great chap. Now, for the last slide, I want to acknowledge to the multitude of friends in the industry who slotted in, believing in our goal and delivering as a vital link in the team. To the creators in the world who inspire better and laudable creations for posterity. To the teachers and trainers who try to give you the backing of the theories and the state of the art. Here is where the peer reviewers come in. First of all, if we have to teach the peer reviewers and then get the certification, it is bad work. I used to say that you should be better than me, or you should have a different software than me to peer review. And in one of the organizations, public sector, I was listened to. They asked me, you tell me whom this should be given to. We should be beyond all that. To the heroes, the managers and workers who gave their all, their blood, sweat and toil all along the chain. I told you that thing which got me the Linka Book of Records. I owe a lot to the project manager who was quality conscious. He was very honest to the core. And the workers, hats off to them. And to my genre of assistants, associates, ladies and gents in my office who helped innovate and form my team. And lastly, my clients, contractors, competitors, and peer reviewers, national and international, who kept us on our toes all the time, helped us in these journeys, which also resulted in national savings too. Thank you.
Thank you, Doctor. That was a very well and very candidly presented. It was a nice presentation, though it was about 5 to 10 minutes overshot with our time. Let's give a big applause to him, with everyone.
Thank you.
And I really appreciate, even at this age, you are so active and have diligently kept all the records of 33 years or 35 years back, whatever you have done. My association with you goes almost 33 years back, when I was involved with, I was in your office as beginning my career under you, when that 88 diameter dome structure was happening.
Yeah.
I feel it's a privilege. Well, it was a very well presented, excellent presentation, and your excellent diligent ways of handling and tackling the problems was really brought to the fore. And we had viewers from not just in Bangalore, across different cities. I could see, from Hyderabad, SP Anchuri, Hari Krishna, from Salem, A.V. Shekhar, and our own members from SP Srinivasan from Madurai. So all these people joining in and listening to you. It has been a long time that I listened to your lecture.
Okay.
It's very well done, sir. And we appreciate your accepting the challenging works at very difficult times. Was very well appreciated. And you always rely on the state-of-the-art designs and materials. Well, not going much into that, there are some questions put forth by various. I have listed about 4 only.
Yeah, sure.
Put forward to you for your answers. First one is from Dr. S.P. Anchuri from Hyderabad.
Yeah.
I have seen some places light rain structure allow the passage of sound more readily than the more solid masonry constructions. How did you do it? First one, LGS will lose strength in event of fire. In the event of fire, what fire protections were adopted? Over to you, Doctor.
Okay. Thank you, Mr. Anchuri, for your question. The thing is that if the cladding is a single layer, you are likely to have this particular aspect of sound traveling through. So if you have a double layer, you won't have that compared to the masonry that you're talking about. And regarding the fires, the American Institute of Steel Construction, they give you fire coatings, for different ratings. and you could have coatings on them, which has come to India also now. Now you have a fire code which is extensive. The Bureau of Indian Standards have come out with one, so you could take care of fire. In fact, to tell you that I didn't know that there was a fire in this particular dome which we did, the 88-meter thing, and not a bit of what should I say, defamation or failure. And I was told this long after it happened. They never told me on the day there was fire, but they were all afraid when the fire took out, it seems. So, it depends on distance and so many factors that come in with respect to fire. And there are cases in which you could make coatings to give you the ratings that you want with respect to fire. Okay?
Thank you. There's the next question from one Mr. Ellen Vivek, who has asked this, that in the composite construction, your point of view on developing long span composite structures, create RCC members in India, how good in cost wise while compared to normal RCC buildings? Sir, your answer.
Yeah, Mr. Naik, I don't want to give you a direct answer. What we do in our office, at least Raymond was my assistant, he knows that all my assistants work, not only me. And I say, this is the problem. Let us all start thinking about it. Anybody with ideas, you're welcome. I give you a day or two, come back. What you're talking about, composite construction, you take a case study, you do a case study which has been done or which is going to be done, and do a composite construction design and costing. Many of the cases that I've seen being thrown out without doing the costing aspect, we are saying, oh, this is not for me, this is for the birds, and things like that. This is the common trait that we have in the Indian genre, or maybe all over the world. They want to do the same thing which your forefathers did and move on. But this is a very, very big technology which should have come to India long back. It didn't come because I will tell you why. The people in the concrete industry don't vibe with the steel industry people, and the steel industry people don't vibe with the concrete industry people. Each is in their own, shall we say, ivory towers. I am sorry if I am very, very direct, but I've noticed this. Although I do steel, I do concrete, I do precious concrete, I do unconventional like shells and things like that. I can feel this. A steel guy will be doing steel all the time and he's not wanting to look at concrete or anything. But times are changing. There are youngsters who are coming up who will want to do something different and be happy about it, and they will bring in this. But my answer to you is that unless you work out, if I had not worked out, believe me, that 88-meter diameter thing, within 15 days, we have worked out the whole design. My preliminary designs will always be like final design only. Why is that? It's because of the great assistance that I have, the softwares that we have. You must always plan yourself for any contingency. Whenever you've got free time, just plan yourself for doing something of this kind. Do you see that man, when he came to my office and said that he wants it in 25-30 days, I didn't batter an eyelid. I just asked him, time has already started. You are running out of time. What are you talking about? So that's the way to do it. I mean, we can do it, provided we all integrate and we all have the confidence that we can do it. Otherwise, we would not. But I feel that that's the next generation thing that should be brought in, and it will be brought in. Especially, you see, in parking structures and things of the kind, that should be brought in, because nowadays either they're going in steel or they're going in precious concrete or something of the kind. They're not taking alternatives. Okay?
Okay, thank you, Doctor. Just to add up a few of your points, for the benefit of listeners, when I worked with you, whenever I was going with a design, we had to go with not just the design, the accomplished part of it also. How much would it cost? What are the alternatives like that? That's the way, he taught us the whole, profession, with under Dr. Ramprakash. Thank you, Doctor. And
can I add only one thing? Can I add only one thing to Mr. Naik?
Yes.
Mr. Naik, the thing is that who are the people who are doing it abroad? all the people who are doing it abroad, most of them are Indians only.
Absolutely.
And why are they doing that? Because of the environment that they have. They can create, they can do, they can experiment, things like that. Here, we wish to experiment. We don't allow people to experiment. We don't think of alternatives, that sort of thing. Thank you.
Well, the last one, I would say, because the time is running out now, this from our own member, Mr. H.R. Girish.
Yeah.
Being a contractsman, he would like to know what type of contract do you suggest for steel buildings? Is it going to be a D&B, design and build, or is it going to be a designer separate or a contractor separate? The first one. Second one is, what is preferred measurement method? Is it going to be a tonnage wise, or you want to have it on a lump sum, or you want to have it in an item rate? And the third one he has asked is about the safety measures we have to follow on all this. Yeah, over to you, sir.
Yeah, very nice questions. The first question, if you put that design and build, people like me will prosper, because when I started practice in the first 15, 20 years, I knocked off 90% of the competition wherever I entered, including, the Windsor Manor Bridge that was pre-stressed in Bangalore. That we got in an all India competition. Finally, we knocked off the thing. So 90% of the cases, and also in HAL, whenever they put alternative designs entertain, we have knocked it off. So large hangars and things of the kind. So I would want design and build, but design and build, there are some loopholes. It should not be like that, because in the American scenario, design and build is because the particular contractor is called a general contractor. He takes full responsibility for anything that happens, including the designs. So no client is not going to ask the designers to sign anywhere and things of the kind. The system is different in the US, but system is different here, because you may not get the design build contractor for a job that you want. He will be good in either design, or he will be good in fabrication, things like that. The second was regarding?
Well, what is the mode of measurement you would like to have? Is it going to be tonnage or lump sum or item rate?
You should have both, and then corroborate the two. It is tonnage. Usually it's tonnage, but it's not a good principle to do it with tonnage, because variation in prices of each of them. So when you do the measurement, you can measure out what are built sections, what are built up sections, and things like that, and then do the costing. So even when you have a dispute, you will not have any problems if you have both.
True. Well, the last one is an appreciation coming from a person from not just a structural design background. He is a metallurgist, appreciating your work. It's hats off to you, sir, for whatever you have done. And then there's a point which has been mentioned by Dr. N.P. Rajmane here. You are an ivory of towers of concrete and steel, which would definitely apply to that. Well, excellent presentation, excellent answers for all the questions. I think we have the time for this only. May I now probably conclude with your great presentation, your humble approach, and your diligent ways of keeping all the records, even 33, 35 years old work, and very well presented. Thank you, sir. Thank you very much. Over to Savina for the next course.
Thank you.
Savin?
Thank you. Yeah. Good afternoon, everyone.
Good afternoon.
It was a wonderful lecture and a very good insight into the steel structure. I would like to thank today's speaker and the ocean of knowledge, Mr. Ram Prakash, sir, for this wonderful lecture. Thank you very much, sir. I would like to thank Mr. Ravindranath, sir, for moderating today's webinar and making it more interactive. Thank you very much, sir.
Thank you.
I would like to thank ACC headquarters for providing the WebEx platform, and I would like to thank all the participants, ACC office staff, on behalf of ACC Bangalore Center for making this webinar a success. Thank you. I have one small announcement. Please join us again on 12th September. Same time, there is one more webinar by Mr. Ram Prakash. Topic of the webinar is various type of concrete shell form projects and coping challengers. Please join us. We will be communicating the link and all the details soon. Thank you.
Thank you.
Okay, thank you, one and all.
Thank you. We'll
Have a
conclude.
great day.
Thank you. Thank you, one and all, sir. Thank you. Bye-bye. Have a happy Teachers' Day.
Yeah.
It's been a pleasure and a privilege to be interacting with my teacher today and spending so much of time. I'm really privileged. No words
Yes,
to
sir.
express
For
that.
all of us, he is the teacher.
Yes.
So particularly Ravindranath is
Yes, sir,
close to me because of his boss. His guru is one Professor Rajsekharan,
Yes.
who's a nonsense person, is a dynamo.
Correct. Well, my classmates from PSG, Shekhar and Harikrishna will also join, because we all were looking out for his class whenever it happens. More than the class, his experiences he used to share, whether it is Los Angeles Bridge or whether it is going to be his association in Germany. He was a man with a lot of anecdotes or a man of experiences.
No, and the passion for sharing. That's
Absolutely.
He checked one of our designs and he used Strudel or so and checked it. And I had told the organization Railway Plan that you should send it to people who do something of that kind.
Absolutely. I fully agree with you, sir. I fully agree.
Right.
Okay, sir.
Okay.
Bye-bye.
Thank you. Bye-bye.
Yeah, thank you.
Good day.
Thank you, Shrikant.
Thank you, sir. Thank you.
Okay, bye.
Thank you, sir. Bye.
Thank you, Diksha.
Thank you, sir.
Thank you. Bye-bye. Good day.
Bye.
Thank you all.
Hello, Ramprakash sir.
Yeah, hello.
Some members are asking for presentation. If you permit, I will share, sir. What's your suggestion, sir?
Who are they?
I'm getting mail from last Saturday. I got one mail. Please share presentation. One member. What can I do?
Last Saturday also.
Yeah.
Today's you can give them.
Okay.
Last Saturdays, I think somebody called me and told them you have been very frank and things like that. So better not to send the last Saturday thing.
Okay, sir. Sure.
You can send today's, okay?
Okay, sir. Sure.
Okay.
Yeah, I will share recordings Monday, sir. Why? Because it takes one day to generate recordings.
No problem.
Okay.
Okay. Thank you.
Thank you.
Bye.
Can I end, sir?
Yeah.